Hello and welcome. Today we're working on how to estimate cost using Excel. There's a couple of different ways we can do it in Excel. So one of these ways is going to be very helpful for you. If you're new, my name is Jeff or Finally Learn. We're teaching accounting. We're in managerial accounting, working on how to estimate cost and cost behavior. So here we have the information where we have units and we have costs, and I did it for months. It doesn't really matter. This month column is not going to be helpful at all. And so this is just made up data. We produce a certain number of units and we have a total cost. Now, the way we can estimate, we're trying to figure out how much is going to be fixed versus how much is going to be variable. And we're going to come up with a cost formula, and the cost formula would be something like y equals mx plus b. Now, the y is the total cost, m is the slope of the line, or that's the variable cost per unit, the x is the number of units, and b is going to be our fixed cost. Now, we're going to work with the high-low method. That's an easy method. You only need 2 data points. And then we're going to do regression, and I'll show you 3 different ways you can show this in Excel. You can model it with graphs, with formulas, or with the data analysis tool. So let's get started with the high-low method. And so the high-low method says, look, we're going to take the difference in the high and the low units. Okay, so what we need to do is find where is our high. Well, it's going to be right here, the June 600. So I want to highlight that so we can focus on that. Now that's going to be our high units, and we're going to find our low units. Well, I think it's going to be the 420 right here in October. So that's our low units. Now, can we find a cost that is higher than 40,900? Yes, we can, but we're not going to pick the highest cost. Can we find a cost that's lower than the low at 34,150? Yes, we can. It's here. But we're not going to pick the high or the low cost. We're going to pick the high and the low units. So here's the idea with high-low method. We have 2 data points, and when we go from 420 to 600, our costs go from 34,150 up to 40,900. So we're going to take the difference in the high and the low costs divided by the difference in the high and the low units. So here's what we're going to do. We're going to take the cost 40,000 minus 34,000, and we get 6,750. Now, so what we're saying is all those extra costs have to be variable costs, not fixed. And so what we're going to do is say, well, how many units did that increase? Well, 600 minus the 420, and we're left with 180. So what we're saying is if our units go up 180, our costs went up 6,750. So 6,750 divided by the number of units, we're going to get an estimated variable cost per unit. So this is our estimated variable cost per unit, $37.50. Now, if we pick 2 different data points, it won't work where we have the same answer. So for this to work, we all have the same answer, is we must pick the high units and the low units. If we pick a high cost and a low cost, it will not work. Now, once we know the variable cost, we can solve for the total fixed cost. So at the low level, here's what we know. At the low level, we know our total costs are $34,150, and it's made up of 2 components, variable cost and fixed cost. Well, we just have figured out that 420 times 3750, that's going to be our estimated variable cost. So if our estimated variable cost is 15,750, we can take the 34,150 minus the variable cost, and we'll end up with our estimated fixed cost, 18,400. Now in this case, it doesn't matter if we use the high or the low, and so the low, we've got 18,400. It should work at the high. It doesn't matter. You do not have to do it both ways. You can just do it one way or the other, but I'm going to show you both. So at the high, our costs are 40,900, And at the high number of units, we have 600 units, and we're estimating $37.50. And so that is our estimate for variable cost of $22,500. So if I take my total cost and take out the variable cost, then I'm left with fixed cost. And my fixed cost here, estimated fixed cost to be $18,400, which is what I got in the low column. All right, so you don't have to do it both ways. You can just do one or the other. So what is our cost equation on the high-low method? Well, it is y equals 37.50x plus something like 18,400. So we can see our fixed component and our variable component to equal the total dollars. So remember, y is our total cost, x is the number of units. So we could plug in 600 times 3750 plus 18,400, and that would give us our total cost. And in this case, it would be exactly, the total cost would be 40,900. Now, if we plug in another number, we're going to have a line that based on this cost equation, and it won't necessarily work out. So if we plugged in 470, we will not get the 37,200. All right, so now the high-low method is easy. It has just 2 data points. We have 12 data points, but it only uses 2. But we have no idea of how good our line is. So how good is this cost equation or this line, this linear model, however you want to say that. We just don't know have any idea of how good that estimate is. So regression is another way to do it. Regression we can use and do a graph. So let me show you how to do this graph. All right, so here I have my same data. And so I'm going to go to Insert on the Insert ribbon, and I'm going to go to the scatter plot. So what I want to do first is I want to highlight all the total cost and all the total units. I'm going to go to the Insert ribbon, and then I'm going to do the scatter plot. And so the scatter plot on this one, it kind of guesses, and it starts at 0, and that's probably not going to be super helpful. So what we want to do is a couple of things. I'm going to click, and I'm going to right-click and add a trend line. So here's our trend line, and we'll do the trend line, and we'll display the equation and display the r squared. We'll get to that in just a minute. I'm going to close out on that, and so I'm going to select all these, going from 0 all the way to 600, and I'm going to say I want my minimum to be, like 400. I don't want it to be so far blank space on the left, so my minimum, I'm going to make it 400, and this will tighten this up a little bit. And then for my vertical, this is X and Y, the Y-axis. I want it to be let's start at a minimum of like 30,000, so we can kind of look at the data. So they do the same thing, 30,000. All right, so we're going to get a slope. We see the slope of the line and see how it works. All right, so let me do this. Let me get rid of some of the background lines so we don't have to look at all these. So here's what we have. I'm going to make this a little bit larger. I'm going to go to the Home ribbon and make it larger, like a 14-point font. Did that work? No. 14-point font. So you can see, I'm going to make it bold so you can see, here's how it works. So now, what you can do in Excel is do just simply a graph that shows all our data points, and it shows our cost equation. So our cost equation is 36.379x plus 18,985. So it's a little bit different than our cost formula here, 37.5 and 18,400. And so what happens is you can visualize it with a graph, and you can actually get the cost equation and also the r squared. Now, what is r squared? R squared is a number when we take the r, which is correlation. Correlation goes from -1 all the way to +1, and if we square it, then it shortens it down to 0 to +1. So the closer this is to 1, the more that knowing X explains the total cost. So we understand, so if I know just the X, the number of units, then I can explain about 79.5% of the variability that we see in the cost. Now, it's not perfect because we don't explain about 20% or so of the variability, but we have a good estimate. You can see that in general, the more we produce, the higher our cost rise. So that's one way to do it. This is using the graph. Now, there's another way to do it. And so it looks like this. I'm going to get rid of some of these numbers. And we can calculate these numbers directly if you want to do that. So there's a function called slope. And let's think about what we have. The 36.379 is the slope. The 18,985 is the intercept. And the r squared is 0.7948. So we can get those numbers directly without doing it in the graph. So there's a function called slope, and I'm going to use the fx to pull up my formula builder. So I'm going to search for slope. So on slope, what I can do is I have to put the known y's, which is our total cost, and our known x's, which is our units, and hit enter. And so this is the slope. So it's 36.378. I'll format these where we can see them. It's a little bit easier to see. All right, so 36.37. So our variable cost is 36.3788. Our intercept, I'm going to search for intercept. That's going to be the fixed cost. So our intercept is, we need our known y's, all our y's, which is our cost, and all our x's, which is our units. So this is 18,984 and about 76 cents. And then we'll do r squared, and so there's a function RSQ. For r squared, it'll calculate based on all the y's and based on all the x's. So it's 0.7948. 0.7948. So we're getting the same numbers we did with regression earlier. Now, one thing we can do is we can use a forecast linear. So here, forecast linear, we need to forecast a straight line. If we forecast a straight line, we can plug in 400 or 500 or 600 or 700, and it will give us, based on this estimate, this cost equation, it will give us the estimate for cost. So let's do this. So we need to plug in 400 here and all the y's. Now I need to make these absolute, so I'm going to do F4. And all the x's, I need to make this absolute, so I'm going to do F4. So hit enter. So our total costs are going to be 33,000. And we don't need the pennies, so let me get rid of these. Let me put a dollar amount in. So 33,536. So at 400, 33,536, and we can copy this down because I've plugged in the x's and y's were absolute. And so now at 600, we think our estimate is 40,812. And at 600, this is 40,900. So our estimate is pretty good based on what our actual data is. All right, we got one more way to do this, and this is regression using data analysis. Now, on the data ribbon, you have to turn this on, and if you're Windows or Mac, what you want to do is quick Google search, say add data analysis to Excel. So here's what you want to do. So if you'll click data analysis, you have all these things you can do in data analysis, and right in the middle is regression. So I'm going to hit OK, and it pulls up a dialog box. I was working on it earlier, so let me get rid of this. All right, my Y, I'm going to take my cost and all the way down. That's my Y, and I'm going to select the label because I have a label at the very beginning. And for my x's, I want to take my units, start with units, the label all the way down. And I'm going to put it on the output. I've set up an output called regression output. And I'll put this starting in cell A1. So I'm going to hit OK. And what's going to happen is this is our summary information. This gives us a complete estimate of our regression. So here's what we know. We have our R is close to 89%. Our R squared is 0.7948. We've had that before, but one thing we calculate now is the adjusted R squared, which is a more conservative estimate of R squared. So if we had that, we would use that. We've got 12 observations, and we can see that the significance of the line is very high. It has a very low number here. And then we can get to the coefficients. And so the coefficients here are the intercept is 18,985 or 18,984. And the units is 36.37. So that this is our fixed portion and our variable portion, our slope. So we have fixed cost and variable cost. We can do these 3 different ways and all get the same number with our regression. So what happens is we did the high-low method. It's easy, but it doesn't give us a good measure of how good our estimate is. But we can do regression really 3 different ways. We can do it with a graph, we can do it with formulas, and we can use the data analysis tool pack where we can actually get all this regression output. And so it just depends on what you need. And you can show this as a graph, show this as a formula, or show this as complete analysis. Hey, thanks for watching. We'll see you on the next video.